This lesson will be on working with regular polygons and finding the area of those. Just a reminder, a regular polygon is where the sides are all congruent and all the interior angles are congruent. When we work with that, we have to introduce a new concept, a new term. That term is if I go from the center of the figure, this is a hexagon, a regular hexagon with a side of 18, you have to draw what is called the apothem. The apothem is the altitude to a side. So if we draw an altitude to the side of this regular polygon, we're going to label that as A, little a, for apothem. So that means our area formula for this is going to be area equals for this 1/2 times the apothem times the perimeter. So there is our formula for the area of a regular polygon. Now that we're going to use that to do this problem, and it's going to involve some trig. It will also be a reminder of some of our special right triangles when we do this. So when we do this problem, what we want to do is recognize that if I draw from the center to one of the vertices, so if I draw this in here, I now have a right triangle. And if you think about it, if I were to draw to all of these vertices and all of the apothems, since this has 6 sides to it, there would be 12 of those triangles formed. So that, what we're in essence going to be doing is this formula is based on finding the area of each of those triangles and adding them all up. That's where we get the 1/2. The A represents the height of that triangle, and the base of that triangle, notice, if this is 18, the base of this triangle is going to be 9. There's going to be another 9 there, and all the way around, if I add up all of those, I get the perimeter of it. So if I add all those triangles up, I get 1/2 times the apothem, which is the same length or height of that triangle in each of them, times the perimeter. So in doing this problem, what I want to do is first of all break it into parts. Let's find the perimeter. The perimeter of this whole triangle is if I take 18 and I multiply by the number of sides, because of 6 sides, 18 times 6, that gives me a total of 108 for the perimeter. Now, once I've got that, let's go ahead and find out, we've got this apothem here, and what we want to do is we want to find out what the apothem length is. Well, we can use this right triangle to figure that out. The problem is we only have one side, and we don't have the hypotenuse, but we can figure out what this angle is. If you think about it, all of the way around here is 360, and so the angle is going to be 360 divided by, remember there was going to be 12 of those triangles, so if I take 360 divided by double the number of sides, in this case 12, that's going to give me how big that angle right there is, because that's going to be one of all 12 triangles there. So it's going to be 30. Okay, so the step there is to find the angle inside this triangle. You take what the 360 is all the way around and divide it by double the number of sides, because there's double the number of the triangles there. If we were to draw all of the apothems and all the from the middle to the vertices. Okay, now once we have that, we can use trig. In this case, I could also use a special right triangle. So just a reminder, only with the hexagon is that going to be a 30. You could use the 30, 60, 90 degree triangle if you wanted to. I'm going to generalize though and use the trig idea. So if I want to find A, I've got the opposite side, and I want to know the adjacent, that's tangent. So tangent of 30 is going to equal my opposite 9 over the adjacent, which is A. Remember, you multiply by A on both sides, equals 9, and then divide by tangent 30, so A is going to equal 9 divided by tangent of 30. Let's do that on our calculator. So what I get is 9 divided by tangent of 30 degrees. Make sure your calculator's in degrees if you're going to do this. I'm going to round this value to about 4 decimal places. So I get 15.5, and then 885. Okay, so that's my apothem length. And if you use special right triangles, you could actually get that, what that value is exactly using our different values. Now let's just go back to our formula for area. Area of this regular polygon, this hexagon, is going to be 1/2 times the apothem, 15.5885, times the perimeter, which is 108. And let's see what that approximately gives me. Let's go ahead and calculate that out. 15.5885 times 108. And I get approximately my value to be about 841 point, and I'm going to say 78. I'm going to round to 2 decimal places. So that's how you find the area of a regular polygon. Our objective was to figure that out. It introduces a new idea called the apothem, which is the altitude to the side. You draw from the center to the vertex, form a triangle, find the perimeter of the entire figure, use trig to find out what the length of the apothem is, or whatever information is given to you, you'll figure that out. And then once you do that, put the apothem in, the perimeter, and you find your area.